Hello, and I want to welcome you to a discussion on systems of linear equations in three variables. So let's get started by looking at some examples. Okay, here is the process you want to go through to solve these variables. And I'll let you pause the video and read after these or refer to your notes or in your textbook. But to look at this graphically, you're used to seeing the x and y plane. Well, when we have three variables, we actually have a new plane added to our original thinking. Here, as you may imagine, where instead of making lines as before, we're going to be making planes on this field instead of lines. And you're going to get answers that look like x, y, and z. So that would denote a certain point on the quadrants. And now to look at some examples, we have the following. X plus y plus 2z equals 11, x plus y plus 3z equals 14, and x plus 2y minus z equals 5. So let's go ahead and start looking at how to solve this. The first thing that I would recommend doing is taking the first equation, the x plus y plus 2z equals 11, and let's solve that for x, because both the first two equations have an x that are similar, that have the same coefficient, and it'd be easy to make both equal x. And the same goes for the third equation. It too has just a plain x that we can work with. So let's subtract the y, and let's subtract the 2z on both sides of the equation in one step. You're going to get x equals 11 minus y minus 2z. And what I would recommend doing is to circle this. And I'm going to change colors. And I would take the second equation of x plus y plus 3z equals 14. And again, we're going to make something equal x. So in one step, let's subtract the y and the 3z on both sides of the equation. So we're going to get x equals, let's say, negative y minus 3z equals, no, excuse me, that should not be equals, that should be plus 14. Okay, and I'm going to box this now. Now if you note, x equals this and x equals this. So we can actually set these two to equal since they're both saying x is equal to each other. So I'm going to do that here. So negative y minus 3z plus 14 is equal to what we have up here in red, 11 minus y minus 2z. Now let's just go through and solve for our variables. And something interesting is going to happen. If we were to add y on both sides of the equation, you'll see that the y's will go to 0, leaving you with just negative 3z plus 14 equals 11 minus 2z. So now what I would like to do is to solve for z by getting all the z's on one side and all the other numbers on the other side. So let's start by adding 2z to both sides of the equation. That's going to give us negative z plus 14 equals 11. So let's work by subtracting 14 on both sides. We're going to get negative z equals a negative 3. And now to make that a positive z, all you have to do is essentially divide by negative 1 or just change the sign of everything, leaving you with z equals 3. So that means we have one variable known. That means z is going to equal 3. So now what I would recommend doing is taking what we have up here in red and in blue and plugging the 3 in, and something interesting will happen. So for here, we're going to have x equals negative y minus 3, and then for z, let's put 3 plus 14. So we're going to get x equals negative y minus 9 plus 14. So x equals just a negative y plus 5. I want to box that now. Now I want to do the same thing up here. I want to say x equals 11 minus y minus 2, and that was z, so let's replace that with 3 as well. So we have x equals 11 minus y minus 6. And what's going to happen, we're going to have y, or x equals a negative y, and then 11 minus 6 just gives you positive 5. Let's circle that. And if you look, these two, this right here, and this right here, are the same line. So that means that once you plug z's equivalent in for these two equations, they make the same equation. So we're needing to work with this last equation. And what we need to do is to write that last equation we have not done anything with yet, the x plus 2y minus z equals 5. And since we know what x is equal to, from what we boxed up here, the negative y plus 5, let's take that and plug it in for x. And since we know what z is, let's plug it in for z, and we'll see what we can get for y. So, in for x, let's put a negative y plus 5 plus 2y minus, and then in for z, let's plug a 3 equals 5. So now let's go through and simplify. We have negative y plus 5 plus 2y minus 3 equals 5. So, simplifying the left side of the equation, we're going to be left with y plus 2 equals 5. Solving for y, we need to subtract 2 on both sides. So that leaves us with y equals 3. Okay, so we have an x, y, and z unknown, and so far we have found y and z, so our last step will be to find what x is equal to. So to do that, let's just take one of these values we have for x, one of these equivalent equations. So let's select x equals negative y minus 3z plus 14. Since we know what y and z are, let's just go through and plug in. X equals a negative y, which we're going to replace with 3, minus 3z, which we'll replace with another 3, plus 14. Remember, we replaced the variables what we found them to be equal to. Simplifying, we have x is equal to negative 3 minus 3 times 3 is going to be a 9 plus 14. When you simplify that, you're going to get x is equal to negative 3 minus 9 is negative 12 plus 14 will yield 2. So x is equal to 2. And now our final way to write the solution of x equaling 2, y equaling 3, and x equaling 3, you can write that as one ordered pair of 2, comma, 3, comma, 3. Because the x will be the first number, the y will be the second number, and the z coordinate will be the last coordinate. And there you have found the solution to that system of equations in 3 variables. We'll conclude with another example in the